Advanced Pre-Calculus, as promised, here we are going through the practice test for 7.5 to 7.6. So hopefully this helps you prepare and study and understand the concepts so you can do really well on this test coming up here. Let me see if I can focus that a little better. All right, so let's get started. So the first one, we're just going to use all of our little techniques here. The first one looks pretty familiar. I would say that this is sine of 3 pi over 12 plus 2 pi over 12. And those are going to shake out to be values that we certainly know. So we'll just write that over here. That's going to be equal to the sine of pi over 4 and pi over 6. So we know those values, and we can just sub in and compute. All right. So let's expand though first. The sine sum is going to, I'm just going to kind of go this way because how the notes are, or how the, I just don't have a lot of room. Anyway, so you're going to sine of this angle and then cosine of the other angle, use the same SIGN, the same sign, and then do the sine of pi over 6 and then the sine, or cosine of pi over 4. Okay, so this is going to be root 2 over 2. This is a 30-degree angle. This is a 30-degree angle, and this will be root 2 over 2. So those are your ratios. So this is going to be root 6 plus root 2 over 4, which is, looks like B. All right, I think you guys could manage that one. I had a lot of questions in class about this one. And so you're thinking cosecant, you're probably thinking 1 over sine, and then you're trying to build 35 with either 60, 30, 45, and just nothing's working. So a good strategy is to go over here and look at your list and see what's going on over here, and does anything look familiar? Well, that looks like it has potential, but that's not really, cosecant has a reciprocal function with sine, and that's not even how it would look anyway. So this one's just kind of here to throw us off. It does say we will not use all the answers. So what's going on here is that the cosecant of 35 is going to be the same thing as the secant of 55. So this is going to be E. So you're like, this is a co-function. Okay, and so, we've got these right triangles. And so if I do, let's just do a real basic one. Let's put 30 here and 60 here. Okay. And, if you were to put all your values in, this would be 1, this would be root 3, and this would be 2. So if you were to do the sine of 30 degrees, you would get 1/2. And if you were to do the cosine, so notice I switched the angle of focus, and I also switched to a cofunction, you would also get 1/2. So the cosine of 60 is the same as the sine of 30. These are complementary, right? Complementary angles add up to 90. And these are cofunctions. Okay, so that's what's being used here. So cosecant is a cofunction with secant, and 35 is certainly complementary to 55. They add up to 90. Okay, now we look at a pattern. This looks like a sine of angle plus another angle. Okay, so it goes sine, cosine plus, sine, cosine, the angles switch. And so that's going to be the sine of two angles being added. So that's 45 and negative 45, which of course is sine of negative 300. All right, so negative 300 just goes this direction. Well, that would be positive 300. So negative 300 goes all the way around here. That would be negative 300, lands in quad 1. And my distance away from the x-axis is right there. And so that's a 60-degree angle in quad 1. And for sine, that would be G. Root 3 over 2. Okay, and a lot of people asked this one in class also. Just kind of maybe use a variable substitution here. and just look, this is 2 cosine squared of some, say, beta minus 1. And that is a cosine double angle formula from your pink sheet. One of the three is that a cosine double angle formula. One of the three is 2 cosine squared of theta minus 1. So just viewing that as a theta. And then, you know, what happens if you were to compute, you take this theta and double it. So this is equivalent to, right here, to the cosine of 2 5 pi over 8. All right, and that is, cancel, cancel. That is cosine of 5 pi over 4. So that is a 45-degree angle. That is a 45-degree angle in quad 3. Cosine is negative, and it's going to be C right here. So this is going to equal, just no room here, negative root 2 over 2. Okay, so that's the concept here, this little connection. Are the following true or false? If false, right, give the correct equivalency. Okay, this is false. What's the correct equivalency? That this is equal to plus or minus 1 minus cosine. That's a half angle. So that's the correct. This one, let's see if this is going to shake out to be. I'm going to need some room here for that one. Maybe I'll even go to the back just to show some, so I don't get all squished for room. So number 6 says cosine of x 1 plus sine of x. Can we get that to equal secant of x minus tan of x? All right, I'm going to just leave this side alone. Pick either side. They both look about the same. I'm going to leave that side alone. So a strategy that we use often is to multiply by the conjugate of either the numerator or the denominator, just however it benefits the problem. All right, so what did this do for me? Cosine of x. Let's leave this alone. And this got me my Pythagorean identity. Okay? So let's see what that looks like. So this is going to be cosine of x times 1 minus sine of x. And this is going to be cosine squared of x. And I can cancel a cosine. All right? So now I've got 1 minus sine of x over cosine of x. And so that belongs, that's an LCD, right? So that belongs to both numerators, 1 cosine of x minus sine x cosine of x. Okay, you know, if you were adding these two things with common denominators, you'd keep the denominator and just say 1 minus sine of x. So there you go. All right, and so this is certainly equal to secant of x. This is certainly equal to tan of x. And this is going to be a true. Okay, true. Okay. This next one is dealing with even and odd functions. So cosine is an even function. So this can just go away. Sine is an odd function, so we pop the negative out front. And that certainly equals, if you then put the negative in front of the whole thing, then this is also a truth. Okay, and then the last one, does this equal, you know, this, again, this is another double identity, double cosine of 2. You have 3 options here. You have this cosine squared minus, or the one we wrote above, 2 cosine squared, or, you know, this one. So this is false. It's not equal to -1. These things aren't -1. These things aren't -1. So for a truth statement here, you could write this, this, or this to kind of give that counter example as to why this is false. All right. And so, you know, if you're thinking of just some angle here, you know, what if we solved it out, and what if it could equal, when you're doing a true or false, you don't say, well, maybe it has to be true all the time. Okay, so these would be true all the time. This is like, well, maybe, depends on the angle. This is not coming from an identity, so you have to focus on the identity. Okay, verifying the following. So again, we're just going to work on one side. And so I'm going to use my half angle identity here, which is 1 minus cosine of x, 1 plus cosine of x. And I can just use, I mean, that's equal to this one or this one. But it's not equal to both, so I'm just going to pick the positive one, and that's fine. All right, and then cosecant here, you know, we could write as 1 over sine, see what that does for us. Nothing right yet. My biggest challenge is this square, right? I want to see if I can get something under there that's square so that I can square root it and get rid of this square root sign. I can't square root both sides because I'm not working on the right side. I'm leaving the right side alone. So this is something we do not that often up to this point, but we do it a ton next year, is we multiply by the conjugate of the numerator. And you might be like, why would you do that? Because, you know, we always do the denominator, but I'm not trying to rationalize the denominator here. I'm just trying to manipulate the problem to my favor. And this is going to do it because up top I'm going to get 1 minus cosine squared of x. On the bottom I'm going to get a binomial squared. So we know that this is equal to sine squared of x. And this is equal to 1 plus cosine x squared. Okay? And so what this does for me is I can now square root something squared. I can square root sine squared, and that's just sine of x. And I can square root the binomial squared, so that's just the binomial. And I've got this 1 over sine. Cancel, and we're there. Okay, and then the next one, I would just sort of think to myself, let's do the math. Let's do the math here. And we could change things to sine and cosine, but before that, sometimes that's a first step, sometimes that's a last step, but let's just do the math here. Okay. LCD, so that would be this LCD of cosecant of, you know, these two guys together, multiplied together. Cosecant t minus 1, cosecant t plus 1. Okay, and let's distribute. Okay, so that's a nice cancellation there. And then on the bottom, I'm going to get this difference of square situation that we'll just multiply to f and l. So first and the last. The inner will cancel out. So this times this, outer, inner will cancel, and then last. Okay, so I'm looking at here, I have got this 2 cosecant, and then this cosecant 1. I want to try to, you know, get this to one term. This is one term. Another thing you can think is this is one term. So I got to get this plus out of here. Some way I got to get this plus out of here because my right side is just one term. So I'm going to turn this into what this is equal to, and this is equal to cotangent squared. That's one of your Pythagorean identities moved around. That cotangent, cotangent plus that 1 is equal to cosecant. So cotangent would be equal to cosecant squared minus the 1. All right, so we're looking good. So now I'm going to go to sine and cosine, I think. This 2 stays up top. Okay, when I send sine squared down, the 2 does not go with it. The 2 is not, the 2 is a numerator. And then cotangent I could bring up as tangent. All right, and I'm going to have some go right here. This is going to be 2 over sine square root of t, and this will be sine square root of t over cosine square root of t, cancel, and 2 over cosine t is secant squared t times 2. And you can't see that. There we go. Verified. Okay, so there you go. There's page 1. I'm going to do this, I think, in 3 different pages, just because in case I mess up royally on a page, then I don't have to, like, I don't know, rewind or try to fix it. So, and you might just need a specific page when you're working, and so that'll maybe help everybody. So I'm going to stop this video and call it 7.4, 7.6 practice test page 1. Take a little sip of water, and I'll make the second page video. All right, bye guys.